Joining us today. Good evening for all of you who are joining from different parts of the country. So I'm Gokul. I currently work with the outreach and admissions team at the Plaksha Tech Leaders Fellowship. Plaksha Tech Leaders Fellowship is a one-year full-time program that interweaves a technical core of artificial intelligence, machine learning with design thinking, experiential learning, leadership, and mentorship. And today I am excited to have with me Dr. Sébastien Foucaud, who will be expending the next few minutes talking about data science, spinning data into gold. I'll take a couple of minutes to try to talk about the Dr. Sebastian's interesting journey. After working around the globe as an astrophysicist and university professor, Dr. Sébastien Foucaud made his way into the world of data analytics, machine learning, and big data technology, and has deep expertise in developing a personalized and user-centric customer journey for product. Dr. Sebastian is the Chief Data Officer at HRS Group, where he oversees all data-related functions such as data analytics, business intelligence, data architecture, and strategy. Sebastian is also visiting faculty at the Plaksha Tech Leaders Fellowship. And prior to joining HRS, he served as the Vice President Data Science at Zing SE. We are really delighted to have you today to speak to you over the next few minutes. Before I hand it over to Dr. Sebastian, a couple of housekeeping rules. If you have any questions, you might be able to see a question and answer tab on your screen. You can always use that to ask your question at any point of time during the session, and we'll be able to take it up between and later during the part. And if you want to come off video during the later half of the session, you can raise your hands and we'll be able to enable you to use your voice to ask your questions. Yes, great. Thank you so much, Dr. Sebastian, for joining us today. Over to you.
Hi, Gokul. Thank you very much. Yeah, it's really a pleasure to be here today. I see the number rising, so that's great to be live, and hopefully one day we'll be live in person again, back to India. So thanks for the nice introduction. As I said, as Gokul said, feel free to ask questions. That's for any. I'm a scientist by training. I've been a scientist all my life. I think since very young, always thought this way, and the prime things that you know and you learn when you're a scientist is asking questions. There's no stupid questions. All questions are viable, so please ask questions and I will try to do my best to answer to them. All right, so let's go into the meat of the into the meat of the talk today. So as advertised, the talk is entitled Spinning Data into Gold, which is, I could have called that the Revenge of the Geeks. It's quite interesting, the development really in the past decades around data that become such a key and critical aspect of business. Always have been there, but I think there's been definitely a surge around it in the past 10, 15 years. With principally the ability of dealing with very large data sets. So the threshold access to storage, to cheap computing power really help increasing the ability for us to acquire and store data and then to process and use it. And that's where this amount of data is starting to be more and more let's say large, that we're starting to be able to leverage statistical or applied statistics. And that's where people like me, who by trainings are natural scientists or physicists in my case, enter into the game. So suddenly we develop these capacities throughout our studies and throughout my time as a researcher and a professor to deal with very large quantity of data and to use them to derive interesting insights and even go beyond, use those insights automatically to generate value to the company. And we're really now, it's really the gold mining, it's the gold rush. All companies want now to be able to exploit their data more, and they're also looking for people that have the right skill set and the right mindset around it to be able to do so. And I think it's increasing focus of all the companies and keep going. So yes, so the agenda for today, unfortunately, I only have 1 hour. I could talk about that for days in a row. Actually, I do that when I'm teaching, but I'll try to narrow it down to a couple of questions that I thought would be of interest for you guys. So the first one is, let's dive a little bit of what is data science, what is behind this buzz of data science. Then I will give you 1 or 2, 3 very quickly example of real life application of data science. Same story, I could do that for hours. There are so many different aspects that we can look into from a business perspective of how we can use data better. Then we'll just lift a little bit the curtain and see what is actually behind this, what is behind data science itself. And I will focus a little bit, maybe for 10, 15 minutes around what I call the AI secret sources agility. So as Gokul mentioned, I'm in the adjunct faculty at Plaksha, and actually the class I'm teaching at TLF is around agility in machine learning. So actually how we can productivize data access and machine learning to the goals of providing impact and business value to the companies. So how we can really create AI, so artificial intelligence in reality. And finally, I will just briefly introduce you for those of you that are not really aware of the details of what's the Plaksha Technical Leader Fellowship. All right, so myself, so yeah, this is me at the top of the La Silla summit in north of Chile. I'm the top of a telescope called 360. It's a 3.6 meter optical telescope. And the telescope that you see on the back there is called the Entity. That's a new technology telescope that I was using at the time. I was probably there back in 2009, 2010. You see, I had still some hair here, and a lot of it disappeared. So I've been doing astronomy for more than 15 years. And I graduated a PhD, almost 20 years ago. And then half of my career I spent it in Asia, in Taiwan first, and then in China as a professor. So I was leading a research group, but I was focusing mostly exclusively on acquiring data, so going to telescopes or automate telescope data acquisition as much as possible, transfer those data throughout the internet and store that into data centers, and then exploit those data centers for research purposes. So what we call virtual observatory, essentially. To this respect, I get introduced to what we call big data technology today, very, very early. So we created our first Hadoop cluster back in 2009 when I was at the National Taiwan University. And so I developed really acquaintance and knowledge about all the technology there. And when back in 2015, I did the switch to the industry, mostly in the management of data science, I could really leverage this knowledge. So I worked for different companies based in Germany. I'm living in Berlin now for the past 6 years, mostly e-commerce or classifieds company. One logo you're probably familiar with here, it's OLX. I was the global head of data for OLX. So to that respect, I came to Gurgaon, Delhi quite often during this period already. And I also had a short period of time where I was also doing consulting in data strategy, and that's where some of the use cases I will show you later on are coming from. So at the time that I work with those large companies, most of the company I work with were in the chemistry or manufacturing industry. So yeah, I have this range of experience, and since 1 year now, I'm very happy to be able to share that also as part of the TLF. So I taught last year a class, and I will do it again this year and probably next year again. Just a few words about the company. So I'm the Chief Data Officer at HRS. HRS is a company in a very challenged industry right now, which is the travel industry. HRS is the market leader for corporate lodging. So what we do is we essentially outsource everything that has to do around booking hotels for companies. We worked with the largest companies in the world, so anyone you can think about, Amazon, Apple, Microsoft. We're also working with Tata, for instance, the TCS in particular. We're working with Alibaba, so it's basically global footprint. And we use essentially all the information that we collect on the travelers. So basically we follow the travelers from the corporate travelers. So we're focusing only on the business travelers, and we follow their journey from the time they are booking to the time that they are actually checking in. And also we process the payment and the expenses claims on the behalf of the corporates with the hotels. We have an end-to-end view of the journey, and we use this information of the travelers to basically optimize the negotiation with the hotels and the portfolio to the benefit of the corporate. So with us, the corporates are guaranteed first that the travelers find hotels of good quality everywhere they want to go, but also that we can negotiate on their behalf, reducing the prices and the rates that are proposed to them. We are present globally for 50 different countries. We are around 1,000 people strong. The company shrinked quite a lot during 2020 due to the COVID challenge. We're working with more than 800,000 hotels globally, and we have more than 6,000 global customers, a fraction of which are those very, very large multinationals I mentioned before. And at HRS, just to mention that, I'm covering everything that has to do with data. So I'm taking care of setting up the infrastructure down to BI analytics reporting in one hand, but also working directly with the product teams, or my guys are working with the product teams to embed data and data science and machine learning directly in the products. Right. What is data science? So, Gokul, can you start with the first poll for me?
Because yes, I'm just doing it right now.
So, according to what you think, what is data science? Is it a branch of computer science? Is it just applied mathematics? Is it a revamp of what we called business intelligence before? Is it just a buzzword with not really meaning? Is it a bit of a mixed bag of all this, or really you have no idea? Let's give it a few seconds. 50%. All right. Okay, Eddie, if you haven't voted now, it's too late. Let's close that poll. Can you take care of that, Google? Because I would like to see the display, please. So, and the winner is, yes, you're right. It's a mix of all of this. So this is an interesting challenge that we're facing with data science, because actually it's an interaction of many different things, and it's basically at the core of almost everything. So let's move on and stop sharing. Yeah, share the results. Yes. All right. Go. All right. So let's move on. So indeed, okay, can I get rid of this? Yes. So the skill set that you need to have somehow to represent, to be able to do data science, is an intersections of three main domains. The first one is really computer science itself. As I said, all the capacities that we have around data in terms of acquisition, ingestions, processing, and analysis, and then beyond also machine learning, etc., come from the fact that we can do that now with the computing facilities that we have. We can deal with large data sets, and we can process the information very rapidly. So you need to have enough knowledge in computer science. But before almost everything, it's about statistics. We're talking about large numbers. So you need to have a decent sample, you need to have high quality data, and you need to be able to run statistical analytics to be able to do data science. And last but not the least, it's domain knowledge. So you need to apply your statistical and computer science knowledge to the domain that you want to apply this information. Without understanding the business context, then basically the insights are useless, because at the end the goal is not really to run statistical model. The goal is to bring impact on the business side, and that requires also to have a good understanding on the business. So as you see, it's quite a full package here. It's a complete skill set to acquire, and it takes time, to be honest. And then the level of complexity goes even more granular if you start looking at all the more detailed parts that you can see in this plot there, when you need to also incorporate a good understanding of software engineering. More and more nowadays, DevOps is quite important. So you need to, usually you build and run yourself the models and the products that you're developing. You need to understand data management, how to access to the data in the first place. You need to be able to pipe the data together. So all the work on the engineering. There's machine learning part, obviously, and deep learning in particular. From a data perspective, you need to have what I call the data wisdom, so the ability to understand what to extract from a data set. You need to be able to visualize, because communication is extremely important. And finally, you also need to understand the context, having enough business acumen. So disclaimer here, no one is expecting to have one person to have all the skill sets, and I'll come back a bit later. What is very important for people like me is to make sure that we assemble teams that can basically work together and cover this entire panel. But at the end, we are talking about what we call T-shaped type of skills. That means that you need to have a broad knowledge of all those things, and then you may have your particular specialty that fits with the rest of the team. So data analytics are different. They have different phases of how to use data and data analytics in companies. Usually companies need to tackle all of them. There's no really priorities. And all those different, let's say, specialization of data and analytics are bringing different level of value, but also are more or less complicated to put in place. So here you can see this arrow is going from the bottom left to the top right, and to represent basically the increase in one hand of the complexity, but at the same time of the business value, which is good. Because if you don't increase the business value, there's no reason to make things a bit more complex. So basically the phases are descriptive, which is what we call reporting in general, or business intelligence. It's just looking on the rear mirror to what happened. Then people will go a bit more into the deep dive and analytics, so diagnostics, trying to understand why things are happening, what are the drivers behind the trend that you see in the past. The next natural evolution there is doing forecasting. So you understood the trends, so you can basically predict what's going to be happening tomorrow. And let's say that the grail at the end is to incorporate all that in your product, that all those basically forecasts and decisions are also incorporated. That's like at the end, you have a product that is able to analyze the patterns and forecast and take the right decisions automatically. So this is basically moving from BI to AI. And as I said, everything starts with statistics. So you need whatever you want to do in data, you always will have to have a component understanding the statistical context. Notions around bias samples, sampling, and probabilistic distribution, etc., etc. So it's not a pure mathematical understanding of statistics that you want here. It's really applied statistics. It's how to use those concepts to derive insights and to generate understanding of what's happening. And by the way, applied statistics doesn't apply only in business. It's usually cover large ranges. That's why you see data scientists coming from different horizons. So physicists like me, because in physics we used to use modeling, statistical modeling a lot, especially in cosmology, it was my field. But social science, a lot of people also come with this type of background. So it's a mixed bag of different expertise there, but what they usually have in common is the understanding of statistics. And then an important point is really to be able to analyze the data, so providing value, and that goes through visualization. So the first thing that you want to do when you have a data set is to look into it. I'm a visual guy, first of all. I've developed with the years the ability to identify patterns automatically from plots. But that's very important part. If you want to be able to communicate or to understand the data, you will need to be able to visualize. So every analysis starts always by visualization. That's important. So you have different type of visualization that you can use, but essentially that's the first steps. Parallel to that, you also need to make sure that you can acquire the data. So how you can plug and pipe the data from the business side. So that could be in web or internet from the interfaces, the click streams of your travelers. That could also be through a CRM, the information about the sales that's happening. That can be when you're talking about manufacturing, is the sensors that you have on the manufacturing line. So there are different ways, IoT, etc., in agriculture, for instance. So there are different ways that we can aggregate this information. This is an entire part of your role as a data expert. You need to understand how to get the data, because very often when you face a problem, the data that you want to be used to answer the question that you are asking, or the problem that you're going to solve, is not acquired yet. So you need to understand how you can get this information. Sometimes that's acquired, and then there's the other side of it, is that you need to be able to extract the information from the database where usually the data is living. So nowadays, this get different forms. There's NoSQL, SQL. We are moving more and more into unstructured data, so you can query through the lake. But essentially, the one language, when I see in the community of data science, always this debate between R and Python. You may be familiar with that. The reality is that the top #1 language you need to learn is SQL. Python comes after to me. But that's an essential part of the job as a data scientist. And finally, which is really what is getting exciting for a lot of us, including myself, is when you enter the realm of automation and machine learning. So it's basically pattern recognition and trend forecasting. So that's all those very, very interesting solutions, algorithmically speaking, machine learning, decision trees, neural networks, clustering, unsupervised, and we can also go for active learning, semi-supervised, and yes, many different other fields there, which is commonly understood as artificial intelligence. The goal of all of this is just not to develop those algos, it's really to apply them to solve a problem. But that's very interesting. So why machines are better than us to do that? But first, they're better at us than recognizing pattern. As I said, I developed this aptitude personally, but the computer is still far more efficient to extract signal from a lot of data than we will do. This is an example here. It's a paper from a few years back already on face recognition and the way they solved the problem of face recognition. So the most, let's say, a common way of solving face recognition issues is just to measure the distance between the eyes. So basically be able to capture the eyes, the nose, and the mouth, and the extreme of the head, and basically featureize the pattern and use that as an input for your face recognition. Here in that paper, they had a more vector approach where they were combining faces together with neural nets and basically create some eigenvectors of faces. That was quite interesting. Bottom line of that is it's always about recognizing patterns. And the other thing that computers are very good at is optimizing. So when you give them a problem, they are really able, the computers are really able through software to optimize very, very high dimension space and complex problems. In this case, this is an interesting application in design. So this is a UK-based company called Arup, and what they do is that they basically use AI for changing designs of objects, in particular amplification for manufacturing. So in this case, on the left-hand side, you see this piece of metal. It's quite heavy, and it's that big, and it's used to rotate the cable. So you see the holes there. You have cables that are basically going through the holes, and it is rotating, and then it lifts very heavy cargos that goes in on ships. So this is basically the function of this piece. And what Arup did is that they created a physical model of this piece, and then they basically run an AI that was optimizing how the piece should look like to minimize the amount of material that you use to build it. So basically to make it far more light. So in the middle, you see what comes from the first iteration. So what they did here is that they kept having a constraint on the locations of the different holes that the piece can be replaced one-to-one somehow. And in this middle piece, they basically set 30% of material. And the last things that looks a compressed version of it, it's only 30% of material compared to the first one. And here they just let the AI go completely crazy. And of course, it has to come with a manual because you need to know where to put the cable in that. But according to their research, this is essentially, you can replace one-to-one those different pieces together. So that just show you a small example of why computers are better than us in this type of things. I mentioned that at the start, you need also to balance constantly the technical knowledge and domain knowledge. It depends exactly on what is your role. We'll come back on that in a minute. But if you're a data scientist, a large fraction of what you need to do is to apply your statistical and computer science knowledge to solve a problem that have an impact on the business. Well, I'm not paid by my CEO just to by my company just to do data stuff. Also, I'm very interested in it, but at the end, I need to have and deliver an impact on the business and in terms of revenue and EBIT, right? So for that, I need to understand also a bit more of what are the needs of the business, be able to communicate with the business stakeholder to solve their problems. So we need constantly to balance that. So data science is foremost applied for business purpose, and that's true even if you're on the back end of very much machine learning or data engineering. You still need to keep in mind what are the problems you try to solve through the product and making sure that you have the impact on the business. So when we are running optimizations of the parameters for machine learning, the KPIs, so the key performance indicators we want to optimize against, the matrices that we want to optimize against, always need to be business driven, right? So for instance, if you want to improve your recommendation, at the end, what you want to measure is the click-through rate, because in the travel industry, traditionally, not for HR, it's a different business model, but let's say for booking.com or makemytrip.com, it's the number of clicks. So a click generates revenue. So what you want is that all your pipeline of data for recommendations behind it is completely optimized for you to maximize your revenue. That's essentially what you're trying to do. Interestingly, data scientist has been called the sexiest job of the 21st century. That's why I was talking about Revenge of the Geek before, because to be honest, when I was younger and saying I was a physicist, people were really were changing conversation. I have the joke is that when I was doing my studies, we were always having this joke. If you want people to talk with you, you tell them that you're an astronomer. If you don't want them to talk to you, tell them you're a physicist. So what are those guys? What are the data scientists? So, well, you get a clue, right? You need to be at the intersections of those different trends. So again, statistics, mathematics, applied statistics, machine learning, and computer science, and then also the business side. So each company come up more or less with its own definition. That's how I classified my people at Zing. So we had Zing before, but at HRS as well. Zing is my previous employer. So we have 4 types of data experts. First, starting with the data scientists. So I have a very particular view of data scientists. I believe that the data scientists are mostly meant there to be very closer to the business, providing insights using complex modeling. So they're very much more there to help the business take the decision, a bit less than there to develop model at scale in production, because for me, that's what the machine learning engineer are doing. In lots of cases, those two terms are merged together. But at HRS, I needed to have this distinction between the machine learning engineer, which is really computer science, let's say, type of people, and that are really bringing those models in production, while the data scientist is very much tuned towards working closer with the business. And on the other hand, on the other side, we have what we call data analysts, which are even closer to the business. They may probably use also sometimes a more simple modeling, but they are very much more focused in analytics and understanding and deep dive and understanding of the patterns with the business directly. Usually they work within the business units. And finally, probably one of the most important of that square is the data engineering, which is really the pure backend guys that are building up all those technology that we use today. So most of the companies now they move into the cloud. So being able to build the pipelines in the cloud, everything that's around data ops, and bring the data in production or the data for the reporting. So or in the data warehouse side, in DBA side, or then in more in the stream or let's say a lake type of data ingestion. So this is a more complete view, and these 4 type of roles require very specific skill sets there. So it's important to make the distinction. So the data scientist job, which was at the start, right? So what is happening in there, right? I will come back on that later, but we need to have a mixed bag of people that work together, because as I said, we need to have some specializations, right? So the data scientist himself, if he doesn't have the support from data engineering, will struggle, because he needs to be able at some point to stream the data into his models or to have access to the information that is acquired. That said, that doesn't mean that data scientists are of the understanding of how to build pipeline. Usually I require from my data scientists also to be able to stream the information themselves. Data scientists that know PySpark, for instance, is quite of interest for me. But that say, we all agree that's not really their job. All right. On the other hand, what I want to highlight in that slide is that we have in one hand the business side, so really getting closer to the business from a product perspective or from a pure business perspective or even sales. So there's always a tight collaboration that needs to happen with the product owners Usually, by the way, at HRS, our data scientists work in cross-functional team with a product owner. But we also have data analysts that work most closely with the business analysts and the strategists in the company to provide them, and the data scientists as well, to provide them more insights that based on the data. And on the other extreme, on the software engineering side, machine learning engineer and data engineers need to collaborate very closely with everything that is around backend, and also a front end, by the way, because you need to create the feedback loops. If you want really to create machine learning, you need to understand what the people are doing. So there's really a cross collaboration here that is important. And we are at the intersection, so data is everywhere. The common understanding of data is to be part of IT, which is actually a mistake in general, I would say. It's important that data is actually part of product teams and part of the business itself. So data analysts and data scientists will probably work at the intersection between, let's say, business and product, while a machine learning and data engineer will be between the business, the product, and the IT and the infrastructure. But we are definitely not the IT guys. All right, so I saw a couple of questions. Let's see. Wow. Yeah, so to your questions about a specific example of how HRS and similar companies are trying to leverage data, I'll come back in the second part of my talk. So in a minute, how could you stay up to date with the daily advancement in AI? So that's a very good question. And that's why I personally value very much training. So the important part is to understand that we're always going to be behind how the things evolve. This technology is evolving super fast. So we constantly need to be re-question ourselves, re-question of solutions. It's really the scientific mindset, right? Your teams in data needs to be up to date of the development of the technology and need to build things in a way that they can leverage this technology and move forward. So I'm a believer of dynamics and statics, in the sense that we are constantly moving and constantly retraining ourselves and adopting the new technology. That's one way. The other part, again, to insist on that, it needs to bring value. So there's no need to bring the latest technology if you don't know if it's going to bring value in the business. So you need to balance that. In one hand, making sure that you bring value to the business, but on the other hand, keep scouting for new technology. And that comes part of training. So at HRS, we actually have streams of training internally. We also have platform of exchange of knowledge. We are starting slowly but steadily to contribute to the open source community as well. What is the view would be the most exciting use cases that may emerge specifically in the NLP in the future? NLP is a very broad range of applications. A couple of years ago, there were a lot of fuzz around voice. I don't think I think my generation is not ready. I'm a generation of typing of emails. My parents were voice; they were phone. Me, are more emails, and your generation will be voice, so that will come again. Application in the business side, CSC, so everything that is customer faces, complaints, etc. There are a lot of things that can be done here with bots, conversational AI, etc. That's more today. On the business side, for us, for instance, curating content. We have lots of information coming from the hotels that is given by the hotels, how we can enrich this information from a text perspective, understand better reviews, for instance, from an LP perspective, and get this information extracted. So there are a lot of applications there as well, at least in my business. Is there any program offered? I'm not sure what you're talking about. But we are going to talk about the TLF later on, and then you can take my class. Okay, we'll go back to the different sectors later on. What many classical mathematicians are critical of data science. So I would say that statistics is the basics, and that's the foundation more than mathematics itself. Of course, you need to understand the math behind it, but statistics is the basis because you will deal with the sample. So all the complex of related with data sets needs to be understood, and it's mostly that statistics, so understanding bias, variance, error types, probability, etc. And then, of course, when you enter into the algorithmic part, there's definitely a lot of differential equation if you go to the neural nets and etc. But I think that's really, really the basics. Papers and articles to read on this. Well, Google. There are a lot of information about data science. There are very, very good classes on MOOCs available as well. And otherwise, you join TLF. We're applying data science can value doing experts approach data scientists first. Yeah, that's where the so the question is around how to identify problems and how do we work that out. That's complex. That's I'll come back on that in a minute. That's part really of how we're going to work, and it's all about collaboration there. So the biggest problem that we have to have an impact is to understand what is the problem, business problem that we can solve. All right. Oh, there are too many questions. I will have to move. All right. I think I will move on. Sorry, guys. We'll take note of the questions later on, and maybe we can do a post. Let me move on to the next part of the agenda because we're already in the half hour. All right, real life applications of data science. So you mentioned that. I will give you only a few examples here because it's really, the list is quite long. But I wanted to sample examples that are coming from different sectors, right? And all of the examples I'm citing here are coming from a personal experience. The first three are coming from use cases that I work with as a consultant for different companies, and there's a use case that was at the company where I worked. So the first one is an interesting one. Atrial fibrillation, it's a heart disease. It's basically make your heart beat asynchronously, let's say, and you need for that to get the right therapy. The problem is that this type of heart disease is rather common, but it can be also confused with other heart disease, and then the treatment will be very different. So for that case, you need to be able to merge information that is coming from directly the electroencephalogram. No, cephalogram is the head. Anyway, the heart electrograms, and also with information about the patient or the patient history itself. The problem is usually at the hospitals, doctors may not always have time to do all the diagnostics. Part of the diagnostics may be done first by the nurses and information conveyed to the doctor, or if you present heart problem and you're not in the place where your doctor knows you very well, that get complicated. And if you prescribe the wrong medicine, you may kill the patient, right? And it's something that as a doctor you tend to try to avoid. So here it was a project that was basically trying to merge this information together. And a lot of things was based on the NLP. And I was basically take mine input patient data that you combine then with the heart encephalograms, and making sure that actually you can predict the risk that is actually atrial fibrillation. It's a classification issue. So that was a mixture first of NLP to be able to extract the information. And then on top of it, we had the decision tree. So the gradient boosting here that was used to make the prediction. The difficulty of this project, as almost always, is how to get the data, because hospitals, like any company, any other company, that is very siloed, so it's very difficult to stream all the information together. On top of which, here there are a lot of privacy concerns, but we are working with a hospital there, and we get the first validation of the approach. As I said, it was as a consultant, so then the project has been passed on to the team there at the hospital, and I'm not sure how far they've been after that, but we get good results with the approach that we had there. Another application, more in manufacturing, that was with an Indian company, by the way. So here I was in the biofuel. So the idea was they basically using algae that are developing themselves to create new type of biofuels. And for that, they need to understand which type of algae is more efficient and had the best basically optimization in terms of energy rendering when you burn it. So they were basically using genetic technology to try different strains of algae, and also combining environmental, phenotypic, and genotypic data. So the environment, how much oxygen you have, external information, but also genetic information of the algae, and try to predict the performance of this different strain. The goal here was to make sure that we accelerate the process of research, that you don't have to try every single combination of environmental strain and every combination of genes, and trying to basically accelerate the process. Again, it was a classification problem mostly, and the idea here was to take partial information from those different trials and merge them together to derive the insights. That's a project that we kicked off. We defined the outcome, the layout of it, also how the experiments should be conducted, because you want it to be statistically sound. So we wanted to make sure that the different experiments were covering all the parameters in a way that we could rebuild essentially the results. And yeah, that was a very interesting project. Again, that's the bad side of being a consultant. That was stop that, is that you propose things, people like it, but you don't know what happens at the end. But that was an interesting project. Very different. That was for a Swiss-based company that was in the outsourcing of flavors and spices. And here, what we wanted to do is to create an analytics framework predictive for predict the supply and demand chain. So that's typical problem that you will have as a data scientist in companies, is that you want to understand how to match the supply and demand, and to optimize basically the entire framework and workflow to associated to risk. Here in this particular case was a plant that was at risk because due to climate change, it was not growing where it was anymore, and we wanted to understand what were the strain between supply and demand. So that's a very typical, let's say, type of project there. Here, you will hear that from mammals very often. We use classified decision trees for trend boosting. Okay, let me dive on this one a bit more, because this is a project that at least I implemented at scales in the company. One of the company I worked for when I was at, since I'm in Germany, it was called Scout 24 or Scout 24. So Scout 24 has two businesses. One is in the real estate. It's called Imo Scout. So basically 99 acres. And one is in the auto industry. So classifieds again, but for second-hand used cars. Those two different businesses were running in parallel, but I was supervising the teams of data in both. So we came up to the idea of how we could be able to do cross-recommendation. So we had a small part of our users that were using the two platforms, and we knew that because they were registered on both, so we could basically cross-match the information. But most of our users were using either, and mostly Immobilien Scout, because there was far a bigger pool or monthly active users that we had at AutoScout. So the idea here was, can we just start to use information and algorithmic to cross-recommend things? So that would be like here, a web page you see on the left-hand side, where someone is on Immobilien Scout looking for houses, and then we recommend them cars there. Right? The idea was to divert part of the traffic that we had at Imo into auto and make it in a clever way. So from a technical perspective, of course, we can do that. What we're using here is factorization machine or collaborative filtering. And then, of course, we can do recommendation auto to auto. We're doing that for a while, IMO to IMO. But because we have this overlap data sets, as I mentioned, we could train the algorithms to make cross recommendations. So I won't enter into the details of the algorithm, but essentially that's what was the output. So here, this is the case. On the top, you have what was searched by the user. These are real images and real cases of a given user. So they were this person was looking at those 4 different houses, and below you see the images of the houses that we were recommending. So here, the recommendation is not based on the images, but the way it's based on the feature and the behavior. So we know the clicks. That's the most important information. So the behavior of user. So here we know that this person click on those 4 houses. We have other person that click on similar houses, so we can make a recommendation here. So you see, it works pretty well. Same applies. So I choose that because these are nice cars. But same applies for cars. So obviously, this guy was looking or this woman was looking at vintage cars, and this is the recommendations that you get. And now, Ron, what happens when you do the cross matching? And that was one of the most interesting case. This person was looking for basically houses in the mountains, and guess what? The recommendations came with networks. And here, the secret again is just because there is a tiny fraction. This is a user, by the way, this is a user that never used our auto platform. So we don't have direct information about his behavior, or we don't know it because it was not registered there. So we couldn't really use this information about which car he was looking for. We just knew about the houses. But we have still a small cases or a small sample of people that are doing both. So we use that basically to educate the algorithms for the rest. But that one was very, very interesting. So I hope that answered a couple of your questions. As I said, it's endless. I could do that for days. There are many, many other cases that are very interesting there. All right, let's see if I can answer one or two questions. Hola, too many questions. I think companies would be directional without the presence of any data scientist. That's not interesting. Let me answer to your question, Arjun. No. So classical people, my CEO has 25 years of experience in his business. He knows his business inside out. He knows lots of people working in his business. He can take decisions based on his gut feeling and his knowledge and his past experience. So I will trust him. And actually, I will trust him more than some of my algorithms. Now, he is limited as well. If he enters into a new, let's say, market that he's not been before with behavior different, then that sounds a bit more harder for him, right? But essentially, he understands well the business. Now, a company, the CEO cannot run every aspect of the company. You need to rely on his people. You need also to be able to measure, understand how much the business is doing. So then that's where data is kicking in, because a sales guy that is 1 year in the company, or a PO that is there for a couple of months, we cannot trust them with their experience. Just don't have any, or limited, far less limited than the experience of my CEO. So then that's where we need data analytics and data science to really, really support the entire company to be able to take the right decisions. And of course, we can also optimize at the company level. So, each pieces, each components of the company will go in certain direction, and you can use data to make sure that everyone is streaming in the same direction as well. So what is interesting, for instance, is that if you have goals and measured by matrices, by data for a given business unit, you will also to monitor what is the impact of your goals on the goals of the other. So everyone just need to share basically a measurement of how their business is doing, but you also need to see the measurements of the impact of what we're doing on the other business units. So all that gets far more complex. So to your answer, for a small business with someone that is very experienced, no, they won't need data scientists. But when you start scaling larger company or entering in different markets, then data will be useful. And data science is just a tiny part. Analytics and analysts won't be able to do anything without the ability to access to data through a DBA. So you will need to have your data warehouse expert or your data engineers. So this is basically all folding up together. Right, I'm running out of time. I have 10 minutes left. What is behind the curtain? So let's run the second poll. Can you do that, Google, for me, please? Yes, good. Thank you. So, which algorithm is mostly used in business when referring to AI? You probably have seen lots of buzz around AI. Every company you're talking with is doing AI, AI this, AI there. All right, so I'm talking about generic. I'm not talking about Google. I'm talking about generic companies. There are a lot of companies doing AI today. So what do you think? So is it deep learning all the way? Is it a mixture of statistical modeling and machine learning? Or there's just linear regressions, or just rule-based decisions, or it's actually usually just marketing? All right. Okay, have you casted your vote yet? It's too late. So your answer is a mixture of statistical modeling and machine learning. I would wish. So yeah, that would be good. And there are a lot of companies entering into that, but this is not the reality. In the reality, most of the business cases come out of linear regression. So this is usually, if you're lucky, what is used behind AI. Most of the use cases I've seen in companies, the mid-size to larger size sometimes, are just purely based on linear regression. Linear regressions carry a lot of power, by the way, already. It's not bad. And the difficulty that we're facing, I'll come back on that in a minute, is the implementation of those algorithms at scale. So linear regression is far easier to implement at scale. So this is really sometimes the sad reality. Everyone wants to go and use AI, and lots of data scientists get trained around this, or machine learning engineer, deep learning all the way. And then when they join the company, they just ask to do linear regressions. So that's something that you need to be aware of. There have not that many companies yet that have entered into the game of proper machine learning. Of course, internet industries are a bit more ahead of the pack. But if you go to finance, sometimes you're very surprised. Okay, let's move on. So business tends to oversell AI. That's definitely the case, and we need to manage expectations at the end. And I like this quote from Swiss Polyax. Before we work on it, artificial intelligence, why don't we do something about natural stupidity? But yeah, this is a problem, and it's our role, especially if you want to become leaders in this field. It's your role to manage expectations, to manage what can be done, but also to make very clear what is behind it, and that it's not oversold by the business. So as these streams are gaining traction in the world, the use cases, the problem that we're facing also is the use cases are ill-defined, mismatched, and there's a mismatched sense of difficulty between what can be done and what is asked for. And sometimes we just have what I call the product placeholder for machine learning, is that there's a product team building everything and just saying, like, in this little box, we will put machine learning later, which is not the right way of doing it, because that's far more complex. So this is problems that you face very often, and that need to be addressed, and to be addressed by the people that are driving, so that are leading basically the startup industry. So just about the mismatch of expectations, I like this little cartoon, which is essentially some business guys coming with a picture with he wants to know where the picture is coming from, and the data scientist saying, well, let me look at the data. Is it coming from that park? And then you say, well, it's a picture of the bird, which bird it is, and then the data scientist saying, like, give me a research team in 5 years to address that. And that's this example is not very up to date now, because nowadays we do a lot of development in computer vision, but that's really a classical case where there's a complete mismatch between the technical capabilities and the expectation of the business. One of the most common sentences I hear is how difficult can it be? And that's usually when you hear that, that's usually because it is difficult. So what you need to have behind the curtain is a combination of technical feasibility, of business impact, obviously, and data availability. And as you see with the arrows, very often you're not at this intersection, right? So you may have technical feasibility and data, but then you don't have any business impact. By the way, lots or most of the data science projects nowadays are run that because businesses decide to hire data scientists, put them in the room somewhere, and then they do something useful for the business. And they don't develop the business acumen that I've been talking a lot. So you want to be at this intersection there, and projects that are at this intersection. Let me move on faster. One thing is important to remember as well is that when you want to talk about machine learning, the core part of the machine learning is just like tiny part of the ensemble of things that needs to be in place for you to be able to use machine learning at scale, right? So you need to be able to access to the data. You need to have the data that is pre-processed. You need to have the ability to validate your models, to extract the features, all the infrastructure that goes behind it. So at the end, it's an engineering challenge before being a pure data science challenge. That's why we need to work with data engineers that you need to have the right infrastructure, etc. Now this gets easier because we have infrastructure as a service. So you can run a lot of things and pipelines quite easily now in the cloud, but nevertheless, this needs to be in place. And the other problem that you can face when you're doing data science is essentially that most of the things that you're doing is just shuffling data around, right? So cleaning, organizing the data, looking for the data, bad quality data, that's essentially a large fraction, 60 to 70% of your time as a data scientist is about this. Where is the data? How I can acquire it? How I can clean it? Is it good enough? And the rest is taking a smaller and smaller part. You see in this pie chart, refining algorithms for persons, mining data 9%. Right? These are poll coming from, in this case, it is I think Kaggle, and this one I forgot where I took that from. So data quality is a big problem, needs to be addressed at the company level. That cannot be just the problem of the data scientist. And that's my role as a chief data officer to ensure the company understand that. And I always use this picture when I talk to management, that you be surrounded with water, because people are telling me, but we have the data, we have plenty of data. Yeah, sure. But is it the right data to solve your problem, right? You can be on a raft surrounded by water on the raft in the ocean and die of thirst, because the water that is surrounding you is not proper for consumption. Well, the same applies with data. You can have tons of data, but if it's not at the right quality or the right data to solve your problem, it's useless. So that's an important part. That's why, as I mentioned before, a lot of the time you need to reacquire data. We're talking about communication. Our role is also people understand what's happening and what are the limits and the constraints. So you don't need to go and try to explain to your CEO the details of the model, or it has been fine-tuned. But what you need is to get him the good understanding of the limitations of the methodology you're using, and understand that not everything is possible. And that's important, because then you will all come with your use case or a case that is on the edge. That's the way human brain is thinking, right? Machine learning is made for the 80%, not for the 20% in general, depending on the accuracy of your model. I had to rush that, but I want to go very quickly at the end on the agile part, because this is the class that I offer at TLF. As I said, the problem that we have usually is that we do not understand really the objective. So you start a data science program, the business does not understand really what you can do with it. Sometimes you don't understand exactly what are the problem they're trying to solve. So that's where it's getting very, very important to iterate very fast. So you don't want to come for 6 months or 12 months projects and at the end realize that what you were going is completely wrong direction. You want to iterate, you want to be agile in the way you develop things, because you want to be agile and iterate as fast as possible with your end user on the business side or on the end user side. So this is where the fail, learn, adapt model is coming from. So you really want to learn fast. That's basically what. So you want to run and sprint, produce things very rapidly, test them, and if it fails, you go back to the drawing board. This is what about agility. Agility is not coming out from flexibility. That's really very sometimes confused there. People think that because we're agile, we can do whatever we want. It's not the case. It's about iteration, about iterating fast. And you probably have seen that in your products. That's what you want, is you want to start spinning out and increase the complexity with time. You don't want to think about how we'll develop the end product. You want to go step by step and increase the complexity as much as you get feedback from your users. Last point I want to make today, because the gong is ringing, I'm running out of time, is about cross-functional teams. So I mentioned that a couple of times, but it's really, really an essential point. No one is expecting people to know everything. What we need is people that understand how to work together. So from the business side, so you can have cross-functional team that incorporate data scientists, campaign manager, marketeer, or your sales force. Data science can be everywhere as long as they work cross-functionally. Same goes on the product side. You need to have POs, you need to have front-end, back-end data engineer and machine learning engineer, and even data scientists working together to make sure that the product that is developed really have the impact that it needs to do, and you need to iterate constantly. So that's why most of the companies, HRS included, we work in following agile principle. In the business, we follow more Kanban type of methodology, while in the product team, so it's more on Scrum, but that's details. At the end, what we want is to iterate, so run project, breakdown project on 1 or 2 weeks basis, and iterate as fast as possible to get the learning. Because if you go wrong, it's easier to come back. And yeah, Gokul, do you think I can still use 5 minutes?
Definitely.
Well, if you're in a rush to go, feel free. But I would just like to talk a few minutes about Plaksha, because I joined this venture 2 years ago, and really at the assumption. The way I run it, so I was consulting a large company in India called InfoEdge, so you probably know Naukri.com. So the CEO of Naukri.com, Hitesh Chobra, I was consulting him on the data strategy, and he started talking about Plaksha because he knew that I had a background as a professor at the university as well. And so, well, maybe you would be interested. And I really fall in love with the concept and with the founding team. We had lots of interaction. That's for me the best way of running a university, and I've been a professor for a while, right? And I left academia for good reason. Plaksha is really the next generation of university, because what we want to do here is to be at intersections between theory. You need to be able to have the understanding of the topics to be able to apply them. You need to understand statistics, computer science quite well to be able to develop AI at scale, definitely. But on the other hand, going for university for 3 years and not having any practical example, when you join a company, you don't know what to do. So the foundations of Plaksha were very much around, in one hand, making sure that you reinvent the education, go experimental, and also self-learning a lot, because you won't learn everything that you know at the university. As we discussed a little bit before, technology is constantly changing. You need constantly to be on the verge. So what I learned the most during my PhD is not the topic. What I learned the most during my PhD is how to learn. Simple as that. How to question and how to learn. What is the methodology for me to acquire more knowledge efficiently? That's what I learned at university. And lots of the university in India or in France were the same. We are just focusing on the content and not how to do that. And that's basically what Plaksha is trying to change, is that we provide the content, but we provide also the practical aspect and the self-learning. And for that, we need to embed our students as much as possible into the industry. That's why people like me, and I'm not the only one, are coming from industry, contributing to the curriculum development and teaching. They are important because we can bring this flavor of how to use your knowledge in the industry and make sure that the classes are tuned for that. And finally, the ambition. We want to be ambitious. We want to change that world, right? You want to change that world. You're the next generation. You want to fight climate change. You want to make sure that your children will have food on the table. So that's basically also the focus here. We're focusing on big problems because that's what it matters. So I think it's a unique combination there to create the next generation of technologists. I'm not the only one to be convinced. There are many different founders for many different companies. Look at the logo board here. You recognize a couple of them that joined this venture and are very vocal around it. And not only, they also put money in where they most stand. And I think that's also quite a unique feature. We have the chance to be supported by a very let's say high level and internationally recognized board coming from global institutions. So there are people coming up from MIT, Purdue, Harvard, Berkeley, in IIT, in the board there. And the Plaksha Tech Fellow. So the Plaksha Tech Fellow was the first impersonation of what Plaksha is about. That's also the program. The first batch was last year. The second batch is ongoing right now. And I was there for the first batch. So that's why I'm so excited about this. So the idea here is to take people that already have an experience, that already have a training, but really bring them to the next stage, right? To the next stage of being the next tech leaders. That's why I insist a lot of it. It's basically training the new generation of people that will bring these decisions, that will bring these mindsets to change the businesses. And based on a combination of leadership, combination of understanding globally the challenges that we're facing, but also the technology. So that's what we try to combine within 1 month, within 11 months. I can guarantee you that it's a very intensive training. But what I liked also, at least for the batch that I taught with, and I'm pretty sure it's the same for now, is that people get very bonded together because it's so intense. There's so much going on that you get to create very strong bonds with the people in the batch. We are around 30 faculty joining, being one of them. And there were around 60 students. And the batch would be in Mohali. Up to now, it was in Gurgaon, but now we're moving to the main campus that has been built in Punjab. And of course, there are directly partnerships with Berkeley and Purdue for this particular program. So there are teachers, as you can see here, coming from Berkeley that will or remotely or move come temporarily to India to teach directly. But we also have a lineup of people that come like me from more business or technological background that also contribute to the teaching. And that's, I think, an impressive program that I will encourage you to join. That's it. So I'm running out of time. I'm very sorry about that. I'm too chatty. Is it online or offline? Both. So actually, the idea initially was that it was partially online, partially offline, but we also encourage people to follow MOOCs. So for instance, when I build up the curriculum for my class, what I give is the list of videos on YouTube or a tutorial that people can look to be ready to discuss with me. I'm not interested in lecturing. I'm interested in practical aspect of what we do. Yeah. Hopefully for me, this year in July, I will be in Gauguin as well. And next year in Mohali. Gokul, do you want to answer to this one? Can working professionals take part in it?
Yes. So Dave, it is going to be a 1-year intensive program. So you might not be able to work alongside the course. So we encourage people to take up this course full time because, as you said, there'll be a lot of things happening for that 1 full year. So usually fellows do not have any other opportunities while working. But however, you do have a capstone project during that 1-year process, wherein you'll be working on certain projects with several industries or even on research projects.
Yeah, last year the batch the batch had 4 people taking a capstone with HRS, and we got the award of the best capstone project last year. By the way, one of them joined HRS as well, Bhutan.
Yes, that's really nice to know. Great.
It's a very intensive program. I remember last year that the students get, because there are lots going on. So you have projects, practical projects. You also have the capstone, we mentioned it. You have many different projects. Some of them are joining with ideas of building up their startup. So it's very vibrant. I would not encourage anyone to work in parallel. I don't think it's possible. Please tell about ECHO and data science program. And the undergrad level, you mean, Nupur?
Yes, I think so.
Yes. Okay. So I'm the right person to talk about it because I'm part of the people who are building up the curriculum as well for this particular program. So at the undergrad level, we have 4 streams that are going to be proposed. One is the data science, business, and economics stream. One stream is around computer science and AI. One stream is around robotics, and one stream is around healthcare. Right? Correct? Yes. Forgot. I'm just focusing on the data science one. So these 4 streams, they will have in the first 2 years common ground, common program, and some differentiation. The data science, business, and economics is very much focusing on how to bring impact in the businesses. So if you remember my separation between data scientist and machine learning engineer, that's really focusing more on building up the next generation of data scientists as I define it. So the people that are using machine learning and data science in the view of direct business impact, not in the view of bringing a product life, right? So that's the focus there. It's a 3 years program. No, 4 years program. The last year is purely practical. And the first 2 years are really setting up the foundation. So we have classes around statistics is an important part of it, economics. There's a lot of things about self-learning also and personal development that's important. Design thinking, so making sure that you can frame your way of thinking and solve the problem yourself. So there's a combination of that. We also have economics a lot, and the foundations for computer science and mathematics there. So it's a full package there. And then when we go into the more, let's say, a deep dive program, so there are big class I would propose around the early data explorations, for instance. So what do you do when you get a new data sets? What are the different aspects that you need to look into? How to frame the problems that is coming from the business? How to communicate and visualize the data with your business? So there will be communication classes, etc. So it's a full program. As I said, each of those streams will have their own specialization later on. The CSAI one, so computer science and AI, is obviously more going into how to bring machine learning at scales in production, or the data engineering part, while the data science and business economics is focusing a bit more into the business side and impacts of it. Yeah. I think we're starting September 2021 in Maori.
Great. I think though we overshot by 10 minutes, I think it's been a really, really wonderful and insightful session. And it was so good to see so many people asking questions and engaging the session. I think, at least for me and many other participants here, it has been a great feast learning about data science today in such a crunch and an engaging manner. Thank you so much, Dr. Foucault, for taking your time today and engaging with us. And I'm really excited to meet you on campus this
Yeah,
September.
I'm very much looking forward.
Yes, yes.
Thank you. Also, I couldn't answer to all the questions. You can find me on LinkedIn if you're interested to talk with me. I'm a busy man. I'm going to do my best, but I'm looking forward to see you as part of the TLF or joining the program as undergrads.